Okay, guys. What we discussed yesterday?
Started beats, sir.
Okay, beats. So what are beats? Yeah, what are beats?
Pleasant sound.
Yeah,
Different.
pleasant sound of different frequencies. Excuse me. Yeah.
Yeah, one scroll up.
Yeah. So let's write here. Okay, beats are what? Two waves here with slightly different frequencies. They are traveling along same line. Same line and same direction. So there will be some mixture of this. It will give you maximum or minimum values, not or and minimum values. So this phenomena of maximizing and minimizing, that is our beat. There is a beat. So let's say here, this minimum of and this one. Waxing and waning. Of sound called beats. So let's take example like y1 equals to a sine 2 pi n1 t and y2 equals to a sine 2 pi n2 t. So if we add both y1 plus y2, we can get to a cos 2 pi and a by superposition formula only. And then we are left with t, then sine 2 pi, and this will be average into t. So for finding n a n1 minus n2 by 2 and NAV average n1 plus n2 by 2. So generally we can write here y equals to same formula I'm writing a for beats sine 2 pi and AVT. A beat we can write as 2a. I'm taking this one as an amplitude. 2a cos 2 pi and a t. Okay, for this one we can say when a can be maximum when cos theta is maximum means 0. Sorry, 1. When A will be minimum when cos theta minimum will be 0. So when it is like this, then A for beat will be 2A. Then here A for beat will be 0. I'm just writing from here only, everything. So Y1 and Y2 are two sound waves, which is traveling. This is let Y1 equals to A sine 2 pi N1T. Excuse me. Yeah, have you done this one? See, out of this one, like, no need to remember everything here. Okay. So what we did, just see the procedure only, because there will be some other other equations also given, or other values will also be given. So according to that, we need to change. So next thing we can just discuss about it. No need to write so much here. We just need to know like basic ideas of a sound, because that's what we are going to do next is Doppler's effect. So for that we need to know a little bit about it. Let's go some basic ideas of sound. So characteristics of sound. Now what do you call music? What do you call musical sound? What do you mean by music?
Pleasant sound.
Pleasant sound. And what do you call noise?
Unpleasant sound.
Unpleasant sound. Yeah. So musical sound means like which is good. Okay. So how do we know which is good and which is bad? Like by diagrammatic, we cannot know, right? Because all the waves are waves only. So we have generalized this musical sound means which is like a regular, we can say, let's make some summarize here, regular and periodic compression and rarefaction. So without sudden change in it. So noise will be, then what we'll write about noise? What can we write about noise? Anyone? We wrote this one. Okay, regular, periodic, compression, and rarefaction. It is regular, periodic. This is irregular, slow, irregular, and periodic, compression, and rarefaction. They may change amplitude. Here, they may not change. No sudden change. Then what will be pitch? So pitch, loudness, and quality. These all are main characteristics of musical sound. What is how high? What is high pitch, low pitch? Like what's the quality? Means like it's hard, it's soft. How much loud it can go? How much low volume? These are characteristics of musical sound. So pitch depends upon frequency. This loudness it depends upon intensity. Intensity. And this quality depends upon number of overtones. What was overtones? Do you remember previous class? It is also a what? We wrote before itself. Where is the diagram? Yeah. Okay. There only somewhere we wrote. Overtones means like a part of some musical notes or harmonic. Okay. Anything else we need to see? Yeah, heard of acoustic guitar and electric guitar. What's the difference? What is acoustic and what is electric? So their name is electro.
Sir, acoustic is something like which doesn't have any, like auto-tune, like amplification.
Okay.
It's more like a direct natural sound we hear, like, singing without auto-tune kind of thing.
Yes. Correct. So it's just a generation process, actual process, you can say. As you said, yes, it is just a process of producing sound. So how shall we write here? Process of generation, like a or movement of sound, or let's say propagation.
It's a electro is like which involves
Ele-
auto-tuning or like it is more electric, like as if we are
yes,
transmitting it through some kind of electric device.
some kind of, yeah. So here electro we can add here like a electrical sound. Electrical sound which is doing propagation and all that. Electrically propagated. We can say like that.
We can say that one has electrical modification and one doesn't.
Yes, electrical modification also, yes. We can do all the modification in that, like so here comes here small chotu topic, that is reverberation. You write this one, then we can go for it. We are not writing so much in this, just little required terms. Then shall I go next? Now, reverberation. Have you heard this reverberation? Anyone? Aditi, Samhita, Veda. Have you heard of reverberation?
No, sir.
Okay. But actually, I guess you have observed already. You might have not known, but you have observed this one already. Now, when you're sitting in the empty room, which is a big hall, okay, so which is like a big hall, you're sitting in the room, and when you speak something, so you see echoing there, you see multiple sound of yours, right? Have you tried this one?
Yeah, a lot of time as a kid.
Yeah, that is called reverberation.
So it's echo.
Yeah. So what happens, like whenever your sounds get, like whenever you're speaking, that get energy get over, again it starts reverberating. So also so many things, so many ways of doing, like it recreate those sounds, like especially for walls only, or like even furniture do. Does furniture do that? Maybe, yeah. Yes, theater hall. So we can make it like this: reflection of sound, or let's say here multiple reflection, which are responsible for series of waves falling on we are the listener. What's the spelling here? Listen. Yeah, I think so. Yeah, listeners here.
Basically, it's echoing, right?
Yeah,
Like
it's echoing.
multiple times. So what's the difference between vibration and echoing?
There's not much a difference here. It's like no much difference here, like similar way. So even have you heard of this shock waves? Shock waves, sonic boom.
Yes, sir. They're really powerful.
Yeah, shock waves. Like what does it shows there? Like whenever have you seen like a fighter plane going away, jet fighter planes, and when you see the tail of like white tails falling behind. So likewise, like whenever any aircraft, so whenever like aircraft is flying at speed of 340 plus, okay, 340 plus meter per second. So this is a sound barrier. Speed of sound in air is 340 something. 343, some book says 340. So let's take a average like a 340. So 340, whenever this aircraft reach 340 sound barrier, it makes that is equals to 1 Mach. 1 Mach. Okay. Just this apart from your studies, it's not in the syllabus thing, but just little information. So whenever it reaches some sound barrier, it will. So this is sound barrier. What is so special about sound barrier? The sound speed of sound in air and your aircraft. This both has reached the same sound barriers. So it has reached this sound barrier. So what will happen when it's reached faster than more than that? So there will be one shock wave created. Means it is going faster than that. In that means what? The aircraft is going faster than sound. So aircraft will fly away, but after that there will be one tail following on it. Then after that you will hear the sound that oh aircraft has gone. Generally we will know from far itself yes some aircraft is coming. But this aircraft will reach sound barrier. The speed is 340. It will be almost on stratosphere. It cannot be on troposphere. Our ears will damage. It's so high speed. From that much far also we are able to hear that sound. Then imagine if we are nearby that. We'll be deaf or blood will be coming out of your ears. So this whenever it reaches this barrier, so that is the first sonic boom. Sudden increase. So that is what shock wave. That is called shock wave. So whenever aircraft reach this sound barrier, cross the sound barrier. Sound barrier means 340. So let's write a little bit about shock wave. So whenever object, we can say a body moving greater than speed of sound in generally 343 meter per second. Imagine the speed 343 kilometer per second means almost 1000. You can divide and multiply and do it. How much it will be? 1.3. How much it will be? One, two, three, four. 4.8 kilometer per second. Sorry, not second. Okay, then what is the escape speed of Earth? Do you remember what is the escape speed of Earth? Gravitation. Yes, guys, tell me what is the escape speed of Earth? No one remember? Aditi, Samhita, Madhusudan, Veda.
No, sir. It's correct. I think it's gonna be very slow.
Very?
Slow.
No. It's very, very high. Very high. Imagine this number. Okay, just imagine this number 11 kilometer per second. Imagine this number 11. Actually, it's 11.2. Let's say 11 kilometer per second. If you reach this speed, then only you can escape Earth's gravitational pull. Otherwise, you cannot escape. Do you think by running you can reach this speed? Or by any vehicle inside the Earth? Can you reach this much faster?
No, sir. Obviously not.
We don't have that much like fastest train in like Japan. It is like 600. Okay, like 600 kilometer per hour. Fine. Fastest car also not is that much. Car, even jet plane also not going this much. It's going, as per my knowledge, it's going what was that? Tejas, yeah. Tejas was about 4 Mach, 4 to 5 Mach. So imagine this speed, 11,000 meter per second. Okay. So what is my point here? This sound barrier is very, very less as compared to this one. And our speed is very, very less as compared to sound barrier. So generally we cannot reach that much fast, only the fastest plane or even like fastest train. Now, what is the problem with this one? Like whenever they are reaching that will be so like high speed so that molecules around it will be creating friction on it, like high speed friction. So whatever car or whatever it is moving at that fast, it will be burned up with the corner friction, and due to that it start burning up. So it start burning up, maybe started melting also. So that is the reason on the road we cannot make a sonic boom there. So there they will have some special format. If you have seen F1 car racing, the car and the clearance of the ground is so much less. It's very, very less. And our car, whenever we are driving like this, our car clearance is like this, so big. Clearance means this one. Because this is for commercial, this is for racing purpose. because we want low aerofoil shape. Okay. This sound barriers, I've done so much in college, I've done so much research on it. I like it. Fine, okay. We are not going too much deep in this one. Otherwise, it will be waste of our time. Not required. So let's go for Doppler's effect. This is important. This one will study a little bit deeper. Not so much deep, but yeah, required. Doppler's effect. Now, have you heard of Doppler's effect? Can you tell me what is Doppler's effect? Just try it. It's okay, right or wrong, doesn't matter.
Different cases of like appearing to sound or sound appearing to us.
Yes. Anything else?
There are frequency and velocity of sound and observer.
Different velocity, different frequency. So how does it change? Suppose, okay, let me help you with that. If you are standing here, I'm standing here, and someone else is standing here. Let's give a name. This is me. Here, let's take here. Madhusudan is standing here, and here, let's take here. Veda is standing here. Okay, so I'm taking one like what is it called? I'll speak with that. The sound will be, I think it's a loudspeaker, right? This is loudspeaker, yeah. I don't know the actual name of it, just loudspeaker. Now speaking this loudspeaker, will both hear sound? My audio will be audible to both. They're standing nearby only. Some 10 meters, some 10 meters. So I'm facing this side. So will both like Madhusudan and Veda both will be hearing my audio? Yes or no?
Yes, sir.
Yeah. Others, what do you think? Both will be hearing my audio, or just Madhusudan will be hearing and Veda won't hear? What do you say?
Depends
Who
on the
will hear and who
frequency.
will not hear? Yeah, what are you saying? Say
Each of
again.
the sound.
I'm sorry, I didn't
It
understand what you're
depends
saying.
on the pitch of the sound or frequency.
Okay, I'm like same way of how I'm speaking right now. Same voice.
But the distance is between them.
Just 10 meters, 10 meters. Nearby only, they are nearby only, both. I'm speaking in the loudspeaker, not just
Okay,
normal
obviously.
voice.
They could hear, sir.
Both could hear, right?
Huh.
Okay, what do you think, Aditi? Both could hear? Madhusan, what do you think? You can hear my voice? No? See, he couldn't hear me. What about Samhita? What do you think?
I don't know, sir.
No idea? Okay. Now, as some of you said, okay, both could hear. Now, if I add a question on this one, both could hear with the same intensity? What do you say? If your answer is yes, then you can thumbs up. Both could hear same intensity. Thumbs up. If you say no, then your thumbs down. Come on, let me see fast. Both could hear same intensity or not? Aditi, Madhusudan, Amita, Shanmukh, Veda. What do you think? You don't know?
Yes, sir. I think.
What happened?
Guessing it. I think
Well,
it's no.
Okay, I'm asking here. Both could hear with same intensity. Yes or no? Tell me. I want everyone's answer. Quick. Make it quick. So that I can tell you answer. Make it quick. Fast. Aditi, Madhusudan, Samita, Shanmukh, Veda. What Shanmukh said? No, you said, right?
Yes, sir.
Are you sleeping or what? Knock.
Sir, I guess they were not.
They won't hear. Okay. They won't be same. That's what you mean. Okay. Veda, what do you think? You can hear same as Madhusudan?
No, sir.
No? Acha. Can someone try to explain why? Let it be right or wrong, doesn't matter. Just can you try it? Why?
So can you show the question once more?
Sure. Both could hear. Okay, my handwriting I just wrote roughly.
So the distance is same, right?
Distance between same only. It's not so much. It's like let's take 10 meter only, both.
So I guess both were here with the same intensity. I changed my answer.
Okay, why do you think so?
So like because it's a loudspeaker, right? Like when we
So,
hear it in like loudspeakers, if it's in the center and two people are on like either side with the same distance, they will hear it with the same intensity. Like in the ambulance and all,
yeah.
the
So that
ambulance
means
siren,
so
we can like
if I
the person is in front or back, they hear it with the same intensity.
no, okay, fine. If I add one question with that, so person who is standing in front of the bus, this is our bus or ambulance, whatever. So loudspeaker will be here, right? It will be running. So if he's standing here and person who is standing here will be hearing same audio, means same intensity, or person who is sitting inside the car, like who is driving, he will also hear same intensity. Now, what do you think, Aditi? You want to change your answer again? You got confused with this. See, I'll tell you this. Okay, good. Well, try.
So the person inside, whoever is sitting inside would hear it with higher frequency, and the person standing outside with a lower frequency, because the bus would pass away if it's a moving bus, or even if it's at rest, like the person inside would hear it louder.
Okay. So fine, let's take this as a homework. I want